In this video, we're going to be looking at another form of quadratic equation, this time called standard form. And you can see a bit of a preview of what this looks like right down here. So standard form is going to be written as we see a polynomial written. In fact, standard form for a quadratic is exactly the same as standard form for a polynomial. Biggest exponent first, then the next biggest, and so on and so forth. So really don't think of that as anything new. It's just the standard form for a polynomial, and a quadratic happens to be a second degree polynomial. Just like we did with vertex form, we're going to go through and find the important parts of the parabola from this. So remember, we had our three different forms. We had vertex form, standard form, and intercept form. We've talked about vertex form already. Now we're introducing standard form. Bet you can't guess what's coming next. Just saying. We're doing the same thing as before. We have all these parts of the quadratic function. We have the vertex, which is right there, the y-intercept, where it crosses the y-axis, the roots, where it crosses the x-intercepts, or where it crosses the x-axis, rather, and then the axis of symmetry that divides it directly in half. Remember, a vertex is just an ordered pair. Y-intercept can be an ordered pair or just the y value. Roots can be just the x values or the ordered pairs, and the axis of symmetry is always an equation, x equals something or another. So now, standard form. If you'll remember, vertex form lets us find the vertex and the axis of symmetry very easily. Standard form gives us a little bit different information. The easiest thing to find from standard form is the y-intercept. But we can also find the vertex and the axis of symmetry. It's just not as easy as it was with vertex form. So the y-intercept, vertex, and axis of symmetry are going to be the things I ask you for. But do realize that the y-intercept is the easiest thing to find from this. So let's talk about how we do this. In standard form, we say that the equation has the general form of y equals ax squared plus bx plus c, where again, just like in our vertex form, a, b, and c are all just going to be replaced with numbers. And then once I know a, b, and c, I can find out all this other information about it. So the y-intercept is the easiest one. The y-intercept is just going to be c, whatever this number here at the end is. And if you want to, you can also write that as an ordered pair. It would be 0c. So whichever of those floats your boat. For the vertex and the axis of symmetry, there's a little more work involved. To find the vertex, we do have to do a bit of calculation. Take whatever b is, and we want to do negative b divided by 2 times a. And so all of that, negative b over 2a, gives us the x-coordinate for the vertex, which also gives us the equation for the axis of symmetry, which is nice. Then once I find that x value for the vertex, I have to substitute that back into my equation to find the y value, which is what this means. F of negative b over 2a means take this value and substitute it into the equation to find what your y value is. So that was probably confusing. Let's take a look at it in a real live example and see if that doesn't clarify some things. So here's my equation in standard form. Just like I did with vertex form, I'm going to rewrite it over here so that we can find our parameters more easily. So a, b, and c are these three numbers. Let's make sure we know what they are. A is the coefficient of x squared. So over here in this problem, a is going to be 2. B is the coefficient of the x term, so in this case b is 4. And c is the constant term, the one that doesn't have a variable, and that would be negative 3 in this case. So for my y-intercept, all I have to do is say that my y-intercept is negative 3. It's the same thing as c. And that is as easy as that. So the y-intercept is exceptionally easy to find. My vertex, well, not as much. We got to do some work here. So remember, to find the x-coordinate of my vertex, it's negative b over 2a. So negative b over 2a, well, b in this case is 4, so negative b would be negative 4. A is 2, so 2 times 2 would be 4. And then negative 4 divided by 4 is going to be negative 1. So now I know the x-coordinate of my vertex would be negative 1. And that also tells me my axis of symmetry is going to be negative 1. Now, for the sake of having some room, I'm going to erase this. That's not ideal, but I do want to have some room to work this out. So if you need to look at that more, pause the video and take care of that. But in the meantime, I'm going to go ahead and get rid of this so we have some more room. Now that we have the x-coordinate of the vertex, this is maybe the hardest part of anything you'll have to do here. What we're going to do is we're going to take our equation and we're going to substitute in negative 1 for x. So I have 2 times negative 1 squared plus 4 times negative 1 minus 3. And all I have to do is enter that into a calculator to find what y is going to be. Well, negative 1 squared is 1, times 2 is 2, 4 times negative 1 is negative 4, minus 3. So 2 minus 4 would be negative 2, negative 2 minus 3 would be negative 5. So my y-coordinate is negative 5. So again, I use negative b over 2a to find the x-coordinate for my vertex. Substitute that in for x in the original equation, and whatever value I get is going to be my y value, so negative 5 in this case. Let's look at another, because that gets complicated quick. Alright, here we go. Find the y-intercept vertex and equation of the axis of symmetry. So again, I'm going to write this thing down so that we can get our parameters. Plus bx plus c. And a in this case is going to be, well, let's take a look. What is a? In this case, there is no number there. It's just a negative sign. So a is negative 1. B is going to be positive 8, because there's a plus sign in front of that. And C is going to be positive 2. So to find my y-intercept, all I have to do is look at C. If only they were all that easy. The y-intercept is just going to be 2. To find my vertex, well, now I have to go back to my equation. Negative b over 2a. B is 8. So negative b would be negative 8. A is negative 1, so 2 times negative 1 would be negative 2. Negative 8 divided by negative 2 is going to be positive 4. So my x-coordinate is going to be 4, and that also tells me my axis of symmetry is going to be at x equals 4. Now I have to substitute that into the equation. So y equals, now I take my negative, and be very careful here. Notice I'm putting that 4 in parentheses. That tells me that just the 4 is squared, and then I multiply by negative 1 afterwards, plus 8 times 4 plus 2, and you can put that all in a calculator and crunch some numbers. 4 squared is going to be 16. Times negative 1 is negative 16, plus 32 would give you positive 16, plus 2 more would be 18. And again, there's no reason why you can't just chunk that all in your calculator to have it do the work for you. And so I find my vertex would be at 418. Alright, so to wrap this up, we have our 3 different types of quadratic functions, and we're finding vertex, axis of symmetry, y-intercept, and roots from them. Standard form allows us to find the vertex, the axis of symmetry, and the y-intercept with relative ease. The y-intercept is really easy. The vertex and the axis of symmetry, it's doable, but it's not easy per se. If we have our quadratic in standard form, ax squared plus bx plus c, the y-intercept is just going to be c, And the x-coordinate of the vertex is negative b over 2a. And once I've found that, I can substitute that value back into the equation to find my y-coordinate for the vertex. And as for the axis of symmetry, it's just going to be x equals negative b over 2a. All right, make sure you memorize that negative b over 2a part. You're not going to be given that on any quiz or test. That's something you just have to know. And just as with vertex form, we'll get some practice identifying these points, and then we'll practice graphing.